Welcome DKWP 小工 aboard. Your learning journey starts now. Ever wonder if a machine could become a scientist? Forget sci-fi for a second. A team at Peking University built an AI, let's call it AI Newton, that did just that. It stared at raw data from experiments, no physics textbooks allowed, and figured out Newton's laws all by itself. Mind blown, right? So, how does this AI magic happen? It uses something called the DIKWP model. Think of it like a mental GPS for understanding. It starts with data, just facts, like numbers from a sensor. Then it becomes information, spotting patterns, like velocity changes. Next, knowledge, building concepts like mass or energy conservation. Wisdom is about seeing the big picture, applying knowledge flexibly. And finally, purpose, the driving goal, like finding universal laws. It's not just a simple ladder, it's a network where ideas bounce back and forth. This framework helps us understand how AI Newton thinks. Let's peek under the hood using our DIKWP map. At the bottom, the data layer gets raw numbers, positions, times, maybe a bit of messy noise, like sameness. The information layer then looks for difference, calculating velocity from position changes, noticing momentum stays constant in collisions. The knowledge layer builds completeness, defining concepts like mass or force and discovering laws like F equals ma or energy conservation. The wisdom layer uses these laws universally, maybe even inventing new concepts like potential energy when needed. And the purpose layer keeps everything focused. The goal is to find the simplest, most powerful laws that explain everything. It's like watching a tiny, super fast human scientist work. Now, this AI discovery process isn't totally alien. It mirrors how humans do science. It's progressive, moving from basic concepts like velocity to complex ones like force, layer by layer, just like Aristotle paved the way for Newton. It's also diverse. Sometimes AI Newton defines mass by hanging things on a spring, other times by watching oscillations. Multiple paths lead to the same truth. This flexibility is key. It shows science isn't just one rigid path. It's exploration, trial, error, and finding different ways to see the same thing. AI Newton is basically a fast-forward version of human scientific history. So, what's next for our AI scientist? Researchers have some cool ideas. First, give it richer semantics, explicitly label concepts as sameness, difference, or completeness. Second, teach it to talk. Explain discoveries in natural language, maybe even read scientific papers. Third, boost its logic. Help it prove tricky conjectures like Goldbach's. And the really wild card. Introduce self-awareness. Use the bug theory. Imperfections trigger growth. Let AI Newton notice its own mistakes and fix them. Maybe one day, we won't just have tools, but AI colleagues who can truly explore the unknown. Pretty exciting, huh?